Okay, so I've just tried to give you an idea as to which are the big companies which are working. IBM is one of the older ones that has been working at it for a long time. Google is there, Amazon is there, Microsoft is there, D-Wave is there, Rigetti, and there are any number of startups. The point is they're still exploring how to do it, because unlike traditional computers where we know that the bits are coming from semiconductor chips and the electronic circuits and on and off is the bit, how we will create quantum bits is a challenging thing, and all these people are at it, and that is why the big opportunities. Next slide, please. Yeah, so what are the challenges? The challenges are stability. So far they've done it. If you have seen the Google thing, it was 53 qubits. Now imagine a computer of 53 transistors, it would be of no use. So stability, scalability, and because of these challenges, the temperatures have to be kept at very low. So when you see all these quantum chips and you see the pictures, the chip is so small, just like a thumbnail, but the rest of the thing is just a cooling system because they have to cool it to somewhat near absolute zero. Next Next slide. Yeah, so it's not just quantum computing, it is quantum technologies. We're talking of new materials, better batteries, pharmaceutical products, and coping with climate change. And this is where the big bets are coming, because people are looking at this to be able to solve the big problems of the world. Climate change, all this fossil fuel being used, they're talking of other things, and so on and so forth. Next. So let me take you to the key concepts of quantum mechanics. You won't understand them fully, but just like you understand that when there is electricity, electricity can heat, electricity can have magnetism, etc., etc., and all electrical technology is based on those principles. First principle is wave-particle duality, which we talked about and explained that it is not only for light or electron, but for all matter. The other thing is superposition. Now, once you have waves, there is a superposition of wave. And this is very different from other things. So you saw that in optics, you also see that in sound. So when you play musical instruments, or in fact an orchestra, there's a variety of instruments, that is the sum of all those waves which our ear hears. So you can have one instrument, and this wave that we hear is the superposition. The same thing happens now with all the matter waves that we get. We'll be able to create superposition, and this is what helps in doing it. Quantum tunneling is another very important aspect that traditionally, you cannot overcome a barrier until you have the energy which will be able to help you overcome that barrier. But because we are now talking of waves, you can imagine a small portion which is able to go through, just like you have interference and diffraction, you will be able to have quantum tunneling. Quantum tunneling is a very well. The entanglement is a more difficult phenomenon. This is a completely new thing for which there is no similarity or analogy, where two quantum particles are so connected with each other and the states are so enjoined that when the particles are moved far away from each other, that correlation or entanglement still remains. Even Einstein did not agree with this. He did not understand it. He called it spooky action at a distance. He wrote a paper called the EPR paradox and so on. Several years after his death, however, there's a person called John Bell who developed this, and they did some. So today's experiments show that yes, entanglement is real, and a lot of quantum computing and quantum technologies are based on entanglement. So this is what the key things are. As you are interested and you will be interested, you can learn more and more about it. But this is like the nuts and bolts. The question then finally comes, so what is a quantum? Sab to ho gaya, what is a quantum? And quantum of what? So the point here is that the many things in nature don't happen in a continuous way, but happen in discrete ways. And this is what the quantum is about. So next slide, please. So it is a quantum of something called action. So in physics, we understand mass, volume, momentum, energy, etc. This is something which is energy times time. It's measured as joule second. And what it is saying is that when in any process, the action involved is a small multiple of h cross. So if it is 1 h cross, 2 h cross, 3 h cross, then it is a quantum state. But if it is 1000 times h cross, it will not be a quantum state. So quantum is the true description. And in some sense, for children of this generation, It is easy to understand. See, you know that all pictures that we see on the television or on the computer, whatever, are made of pixels. Pixel is a smaller, and when you see that, sometimes you call it pixelation. So you can see the pixels itself rather than the pictures. A quantum is like a pixel of energy times second, which is called action. And it is when there is, you can see each of these pixels, pixelation, that is quantum mechanics. When the whole thing is a continuum, you see the full thing as a picture, that is classical physics. Next. So becoming quantum ready. Basically what we say that given you an idea that first of all, the reason you should be ready is this is what is coming before you. So you can either be a leader. Somebody made a very nice thing that in the future, either you will be telling the computer what to do or the computer will be telling you what to do. Which side do you want to be? So if you want to be on the side that you tell the computer what to do, then that is the thing. Next. So to be quantum ready, yes, next. So first is you have to become a self-learner. Because there is nobody who's going to teach you this in a recent amount of time. So till you do your BSc or MSc or BTech, MTech, nobody is going to tell you. So you have to learn yourself. So that is one of the most important thing. And Malcolm now has described this. Also, those of you who are in education know that the term for this is called heutagogy. So we say, and pedagogy is for teaching small children, andragogy is for teaching grown-ups, and heutagogy is for self-directed learners. So once you decide that you want to learn, fortunately for us, there are lots of resources. Next. So you learn physics, next. You learn maths, next. You learn biology, next. So we are at some of my favorite lines from Charles Dickens, which was written in, I think, 1875 about the French Revolution. It was the best of times, it was the worst of times. It was the age of wisdom, it was the age of foolishness. It was the epoch of belief, next. It was the epoch of incredulity. It was the season of light, it was the season of darkness. It was the spring of hope, it was the winter of despair. Next. We had everything before us, we had nothing before us. We were all going directly to heaven, we were all going directly the other way. In short, the period was so far like the present period that some of its noisiest authorities insisted on it being received for good or evil in the superlative degree only. So if you will learn, next. So if you learn quantum mechanics and quantum technologies, it will be the best of times. If you won't, it will be the worst of times. And quantum is about taming the very small. So those of you who are interested, and some of you may already know, this is called the standard model in physics. And it talks about the quarks and the gluons and the vector bosons and the Higgs boson and so on. So tomorrow we are moving towards taming the very small. Our past has been about taming the wild. Next slide. Next slide. We tamed horses, we tamed elephants, we tamed tigers into cats, wolves into dogs, and so on and so forth. So that was 10,000, 12,000 years ago when we were starting to dominate the earth. And today we are talking about taming the electrons and the protons and the gluons and so on. And this is going to create a completely new world. Next slide. To learn more, we have books and MOOCs and TED Talks, YouTube, blogs, even Facebook. You'll be amazed that there are at least 4 or 5 groups on Facebook on quantum technologies which are telling you about how to do this and so on and so forth. So the much maligned Facebook by people is actually a great source of learning for this thing. And then, of course, you have all the others.